Okay guys, November 18th, graphing inequalities in two variables. Hey, it's your second chance to watch a video made by me, because I'm not here again. So we're going to graph inequalities in two variables, which means we practiced graphing equations last time. Now we're going to practice graphing inequalities in just slope-intercept form. So, one thing to remember with these inequalities, just like when you're graphing an inequality on a number line, you have this boundary and you shade one side. So now on the coordinate plane, this half plane is like a line and it separates the plane into two sides. So you're going to have to shade one of the sides of the line. So this, again, we're using this word boundary, and this line is going to act like a boundary, and you're going to shade one of the half planes, so either above or below or left or right. Usually we're going to think above or below because we're going to be comparing to y, either greater than y or less than y, or y is greater than y is less than. So when we're dealing with these linear inequalities, so I think we're going to go right into an example here. Example 1. And it says graph the following inequality: 2y minus 4x is greater than 6. So let's go over the steps to do this first. We're going to solve for y. If it's not solved for y, it's hard to graph because we need to know the slope and we need to know the y-intercept. But be careful when you're solving for y. If you multiply or divide by a negative, remember that the inequality sign has to switch. Here we're not going to multiply or divide by a negative because when we add 4x to both sides, we get 2y is greater than 4x plus 6, so now we get y by itself by dividing by 2. So we'll divide everything by 2 and we get y is greater than 2x plus 3. Okay, so we have solved for y. We've done the first step, and that sometimes is the hardest part because you got to be careful. But this one, the inequality sign didn't switch, so we're good. So now second step, we got to graph the boundary line. So, and you have to decide if it's going to be a solid or a dotted line. Well, if it's got a equal to symbol underneath the greater than or less than, then it's going to be a solid boundary. If it's strictly less than or greater than, like it is underneath dotted, then, and like it is here too, it says y is greater than, then we're going to graph a dotted boundary, or some people call it dashed. So we start with our x and y axis, and then we start on the y-intercept of positive 3, and then we notice that the slope is 2, which can also be written as 2 over 1, and so we're going to go up 2 over 1, put a point there, and follow it a couple more times, or even think of it as down 2 back 1, and follow that a couple times, and then graph the boundary. Okay, it's a dotted line. Notice we're just using these dots because it has to be greater than this boundary. It can't be equal to this boundary. So your solution is going to be like that open circle on the number line. But now we're dealing with two variables. So our boundary isn't a point on the number line. It's a graph on the coordinate plane. It's a line. So now step 3 is to figure out which side we need to shade in. And so we're either going to use trial and error or logic. And let me just show you the logic real quick so that we can figure out which half plane to shade. So logically, actually I'm not going to write it, but logically it says y is greater than. So I would look at the y-axis and say which y values are greater than this boundary. And so I'm looking at the y-axis, and I'm going to shade above, so I'm going to shade it, and a lot of you guys might say it looks like you're shading to the left when we do shade this, but it's actually above this. I'm only thinking above or below because I'm comparing to the y variable. Okay, so trial and error. Pick a point on one side, 0, 0. Okay, great. Plug in 0 for both of them. You get 0 is greater than 6. That's false. You should not shade that side. So let's try the other one. Negative 4, 4 is a point on the other side. This should be true, and then I would shade that side. So what I get when I plug in 4 for y and -4 for x. Sorry, those are mixed up, guys. Sometimes that happens. But that's the y value when you look at the coordinate plane is 4, and the x value is -4. Always x comma y. So then we get 24, because 2 times 4 is 8, and -4 times -4 is positive 16. 8 plus 16 is 24. Is 24 greater than 6? Yes. So we should shade in this whole side. And notice everything on that side is shaded in. It doesn't just stop, like that boundary keeps going and we shade in. Now logically, it's above. You use the y-axis, so we did show it. It makes sense to be shaded above because we're looking at the y values there. Okay, let's look at a few more examples real quick. If this and notice that we're just going to follow these 3 steps. Okay, so example 2. Graph each inequality. And going to kind of just show a few here. We've got x is greater than or equal to -1 and y is less than 2. Now let's look at this part A. This is the only time that you can't solve for y. If there is no y there, you can't solve for y. Therefore, that means there is no slope. We call that undefined slope, or a vertical line. So this vertical line should be going through the x value of -1 right there. Now, why am I doing a solid line? Because it says greater than or equal to. And then this is the only time you'll look left or right, is because there is no y to compare to. So I'm going to use the x-axis. And which values on the x-axis are greater than -1? Well, 0 is greater, +1, all the positive numbers. So it's shaded on that side. Okay, let's look at this y is less than 2. Now notice that there is no x here. So that's going to give us something else. It can still be solved for y. In fact, it already is. So it must have a slope. But the slope here is actually 0, because I could rewrite this as 0x plus 2, which would still be just 2. So I'm still writing the same equation. Y is less than 0x plus 2. So a 0 slope is a horizontal line. And I'm going to start at +2. And it says strictly less than, so guess what? This is a dotted line, or a dashed line. And I'm looking at the y-axis because that's the logical way. Y is less than 2, so I'm going to go down. And so I'm going to shade below. So you can learn more on Alex, but I do want to show you one more example. So if you get this, you can stop the notes. If you want to see one more example, or actually 2 more, so part C and part D, here's how to do these. I'm going to talk about them a little bit less, but notice that I circled the slope and the y-intercept. I started at the y-intercept of -2, and I went up 1/2 to graph that. And then it's a solid line because it said less than or equal to, and then it said less than, so I'm shading below. Okay, now this one is one where I'm going to end up minusing 2x from both sides, and I'm left with -y, because I respect the negative in front of the y, is less than or equal to -2x minus or plus 5. But now look, I have to get y by itself totally. So I got to divide everything by -1. Well, what am I dividing by? A negative number. So the inequality sign is going to switch. Now it's y is greater than or equal to positive 2x minus 5. So now step 2, graph the boundary. Start at -5 and go up 2/1 from there. Go a few times. I like to do 2 or 3 or 4 times. And then the boundary is solid again because it says greater than or equal to. And then greater than, logically, should be above. So I look at the y-axis, and that way is above. So I'm going to shade on this side. Yay. Good job, guys. If this still doesn't make sense, go into Alex, try to look for graphing inequalities, and try to master this. Or use the, this problem is on the practice test, or problems like this. All right, have a good day, guys.